This slide presents the inherent strain method in the LPBF process simulation. Uh, the classical inherent strain method at first introduced in the welding mechanics. Uh, According to this theory, the total distortion can be obtained from the summation of elastic, plastic, thermal, phase transformation, and creep strains. Since these two strains, the phase transformation and creep strains, are very, very small and they have a infinitesimal value, and according to the fact that at the final cooled stage, the thermal strain is vanishes and all the elastic strain are released. So the final inherent strain value uh, mm, will be equal to the plastic strain. However, uh, this theory, I mean the classical theory, couldn't capture an accurate prediction of the residual stress and distortion in the LPBF process due to the uh, multi-layer effect in the additive manufacturing with a very fast-moving heat source that causes so that the stress development and the elastic deformation in the lower deposition will be affected by the layer by layer contraction of the upper deposition. So, in the classical inherent strain theory, uh, it didn't actually include the multi-layer effect because it was based on the welding mechanics. So, the modified inherent strain method was introduced to account for the contribution from compressive plastic strain at the intermediate state and the influence of thermal contraction coupled with the interlayer effect at the steady state. So, what are the intermediate state and steady state? By take a look at to the formation mechanism of the compressive tensile stress and strain due to the thermal expansion and contraction, we can say that uh, the highly localized heat input induces uh, steep temperature gradient in the vicinity of the melt pool, and it results in a non-uniform thermal expansion. So this thermal expansion is constrained by the solidified metals, and it induces uh, it generates the plastic compressive plastic strain. Since at the elevated temperature, the yield strength and the elastic modulus decrease significantly, uh, so the heating process generates compressive strain. When the depositions further cools down, thermal contraction occurs, and uh, you know uh, this thermal contraction is caused by the surrounding solidified materials, and the material would develop the tensile stress and strain. So the intermediate state can be interpreted to the time step when the material, when the compressive, the compressive stress and strain reaches to the maximum value, and the uh, material properties like the elastic modulus and yield strength significantly decreases. And the steady state uh, is referred to the time step when the whole part is cooled down to the ambient temperature. So the new inherent strain The modified inherent strain method introduced the inherent strain value according to these two stages, that including the plastic and elastic strain at the intermediate state and the elastic strain at the steady state. So by this formulation, we can decrease the accuracy and minimum the accuracy of the classical inherent strain method in the metal additive manufacturing simulation.